The problem states, just before 6 p.m., students enter the classroom to find Mr. Fees dead of an apparent homicide. At 6, the temperature of the body is 80 degrees, while at 7 p.m. it was 75 degrees. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? So to figure out this question, we are going to use Newton's law of cooling. T equaling temperature, T ambient equaling temperature of the room that the body was found in, T object equaling the temperature of the object at some given time, aka the dead body, key decay constant equalizing the decay coefficient, and little t equals time. First, we need to figure out K. The reason why is because at any given point, the body is decaying at some constant rate, and we can use that to figure out more or less when the body perished. So using the same formula as above, for T, we're going to use 75. That is because when the body was discovered, it was 75 degrees. Then 70 for ambient, which is 70 degrees at the room was kept in, plus 80 minus 70. 80 degrees is the body initially at 6 p.m. minus 70 degrees, which is the ambient time, minus K, and time is 1 hour. Time of 1 hour is from when it was discovered and then when the police came. So simply 80 minus 70 is 10, and I subtracted 70 minus 75 to put everything on the same. So it's 5 equals 10 negative K of 1 hour. Once again, I simply distributed by dividing 10 from E and putting it on the other side equaling 1/2. To get E over on this side, simply what you need to do is get the natural log of 1/2, which equals negative 6.693. Simply what's going to happen now is, since there's both negatives on each side, it goes away. K equals 0.693 over 1 hour. And if you check your calculator, it's actually log of 2 over 1 hour. The only reason I'm keeping hour is so that when we look up the time of when the body perished, it's easier to convert. Now, we're going to determine the time elapsed between when the body was found and when it actually perished. Let's go back to the question. We're still using the same equation. So now we're using 80 degrees because that's the time it was found initially, regardless of when the police came. Equals 70 degrees, which is time ambient, plus 98.6. The reason I use this number is because that's about the healthy temperature of a human when it's alive. So I did some guessing there. Minus 70 degrees, because that's the ambient time once again. And then we're going to use the K that we used earlier, the constant decay, and we're finding T, so I circled it. Once again, we're doing the simple thing of 98 minus 70, 28.6, and then 70 minus 80, which is 10. Now we're going to divide it once again. 10 divided by 28.6 equals E negative natural log of 2 over 1 hour. So we're going to, once again, we're going to get the natural log of the next number. So natural log of 10 divided by 28.6 divided by natural log of 2. That will give you 1.5. And since we kept the hour there, I can say that I have 1.5 hours. Now the way I figured out when the body actually perished, if I got 1.5 hours, that is more or less 1 hour and 30 minutes. If I take 6 p.m. between the time the body was found minus 1 hour and 30 minutes, that roughly gives me 4:30 p.m. Thank you.